Hi everyone, hope you are having a great day at TestFlix. Today I'm going to talk about transforming software testing with the power of desktops. Before that, I would like to introduce myself. My name is Kumar Abhishek and I'm in the software industry for more than 10 years. My area of expertise is video streaming, content delivery networks, and network domain. I'm currently working as an engineering manager leading a team of estate engineers. Here's the agenda for today. I'll start with talking about traditional software testing challenges and we'll walk over to the desktops introduction, followed by desktops strategies, primarily focusing on test environment management, test data management, and continuous testing. We will also look into the shift left testing and continuous integration, and we'll end the presentation with the desktops takeaways. Let's get started. One of the major challenge with the traditional testing was a lot of time the automation tests used to fail because of test environment or test data issue. And why does it happen? Let's understand the traditional testing first. Traditional testing is also known as waterfall testing is characterized by sequential processes. That means testing activities will only commence after software development phases has been completed. In traditional testing, testing activities like setting up the test environment or setting up the test data is done manually. This can lead to problems. Think of a scenario one has to set up the environment and test data every other day. And there are high chances one can forget to install a particular module or place a particular data file, and that can lead to failures and, in fact, can lead to the invalid testing or unrealistic testing scenarios. So, overall, the process is very time consuming and also error prone and is not efficient. That is what desktops, short form for testing operations, is trying to solve. It's a concept, a culture, a mindset that aims to make life easier for the software teams. It focuses on enhancing or automating the software testing procedures. Most of you must have heard of DevOps, which is a bigger superset of desktops. Desktops aligns with the principle of DevOps but focusing on the testing procedure automation. It optimizes how the testing phases work in a different STLC phases. It promotes the collaboration and automation, and it leads to the better quality of software, finding issues early in the software development lifecycle. The entire STLC process gets revives and gets more efficient. It manages the testing process tools, resources throughout STLC with ease. Let's look into the test ops strategies. Let's start with the test environment management. So here are my top six, strategies for maintaining a healthy test environment. The first thing is we need to understand the requirement. What what our test environment looks like? Is it a development, staging, or production like environment? It is important to understand the need, purpose, and configuration for these environment. It can be as simple as the OS version it's working on, or the database version, or the network settings for these environments. It also introduces the concept of the infrastructure as a code. This is very important to understand because the test environment should be repeatable and with the ease and consistency, and that's where the tools like Terraform and Ansible comes into the picture. Terraform has a strong orchestration capability which can which can automate your infrastructure, and you can recreate the infrastructure again and again on a consistent basis. Ansible can be used for configuration management. These two tools can even use, like together and can complement each other. There are other infrastructure as a code tools too. Then it's always very important when you are testing in different environment that these environment doesn't overlap with each other. And that's where the containerization and isolation comes into the picture. Docker is a tool which can package the application and dependencies together. And you can have like a sandbox kind of version for the isolated dev or test environments so that it doesn't step over each other. Another important thing is to make sure that we have a proper version control system which provides a traceability for any change in the test environment. There should be automated approach to reset the environment after every test case execution. We should also document the environment, how the test environment is, what are the dependencies and different settings. This will ensure that we have a no manual intervention, while setting up the test environment, which will save a lot of cost. Cases will be more deterministic since the environment issues is no more the problem and it will improve the overall quality. Let's look into the test data management. Again, my recommendation would be to start understanding the requirement. What kind of like source or type of data we are talking about? Is there anything specific about the data for our testing? We should maintain the data as a code. So again, we'll have a version control system like Git, which will help us, tracing the previous changes and ensure that we have the traceability. We will also introduce sort of a data generation rules. Data can be generated based on different rules and based on different use cases. The ability of data generation can be achieved using different tools which are available, or one can write their custom tools. We should ensure that all the personal information are masked and the information which are sensitive. The data refresh is another important key feature. Think about the case that okay, the data can get outdated. And when it gets outdated, there should be a way to recreate the new data which is more apt for the software testing. And this thing cannot be done and the model won't be scalable if somebody is trying to do it manually. So there should be always an automated way of doing it. Since today's testing demand different environment to test with, so we need to ensure that there is a proper environment data binding. This can be achieved using a different environment configuration file for different test environments. The fixing the test data management process will go a long way. It will be easy to integrate the automations. It will ensure that there is no failure due to invalid test data. Data traceability will be easier for any automated test which can help in debugging. It will be easy to manage multiple test environments. Let's look into the continuous testing and why it is needed. We all know the bugs are the cost. With one of the stats, one of the source I have pasted here, which shows that if a bug is found in the requirement of the architecture phase, it's the cost is around 2x, but if it's found in the production or the post release, it goes to 30x. So the cost increases exponentially over the different cycle of the software development life cycle. So we need to ensure that we are doing a continuous testing so that we can catch the issues as soon as possible. And this process will be iterative because the way today to software development works is you'll have a iterative development. So we need to ensure that we are running our tests in all phases of software development lifecycle. This will ensure that developer gets rapid feedback and they can fix the issue. This also brings in the interesting concept of shift left testing. This concept tells that we should try to move, earlier phase of STLC for any testing activities. What does that mean? When people ask me, I try to explain that a testing activity should start as soon as the PRD is handed over. For those who don't know what PRD is, it's a product requirement document written by product manager which explains that what is the requirement of this product. As a test engineer, one should consume that document, of course, review and criticize the document if needed, and make sure that we can think about the different test cases scenario right away, and which will also help us to understand, if we need any utilities to be written to take care of those test scenarios automation. That way we can get started as early as possible in the SDLC. And this will also help in finding the issues earlier in the cycle and getting the resolution faster. And overall, it reduces the cost and effort to fix the defects. For shift left testing, it's very important to have the test driven development mindset. So, what is the TDD mindset? It basically says that you start thinking about the testing even before the first line of the code has been written. This will ensure that we are testing the things iteratively and make sure that we have a expanded test coverage. Again, the shift left testing says that the software quality is shared. It's just not the responsibility of testing team. This brings the different teams closer, whether it's a development testing or the operation team. For for implementing a good shift left testing strategy, it's very important to have a robust CI/CD framework. Let's talk about the continuous integration. These are my top key features for any continuous integration framework. Of course, it should be available at most of the time. So I says 4 nines, which means 99.99% of time. It should be able to trigger automated builds. It should have like a faster feedback loop. There should be a way to do a static code analysis so that anything which is not adhering the coding standard is caught earlier in the cycle. It should have the PR gates. What does that mean? If somebody raises a PR, it needs to go through the bunch of test cases to pass, then only it can be merged to the main code line. So it should also ensure that there's a stable master trunk at all the time. The artifact generation is another important thing because this will help us to trace back, for any debugging. Parallel builds is on optimization to make sure that okay, we are getting the test reports faster and we are building asynchronously. Containerization infrastructure as a code I already talked about in the previous slides. Let's look into a model, how a CI/CD system can look like. If you see on the left hand side, let's say that okay, PR was raised on the Git, so that should trigger a Jenkins job, which will technically do the fetch the sources from the Git and set up an environment, and that's where your infrastructure as a code can come into the picture. Then it will build the component using the master code line and a PR on top of that, and will run the test and generate the reports. If everything goes fine, then it can be merged if it's code reviewed, and if not, then the developer will investigate the failure. This can go in an iterative process. And if the PR is merged, let's say there were like multiple PRs coming at the same time, and all are merged to the main code line, and that will trigger the another Jenkins run, which will ensure that now we are going to test on a master branch with all the PRs in. It will build the components and run the test, generate the report, and if everything is passing, then we have potential release candidate. And you can always integrate with the continuous deployment to ensure that it's also deployed. So what are the takeaways? So the first takeaway is like desktops is pretty much meant to optimize and automate the software testing processes. It also enhances and accelerates the testing, collaboration, and improves the software quality. It aims on a streamline and enhance your testing operations. And that's very important in today's competitive software development landscape. Also, we talked about the shift left testing, and that is a way to go forward. Before I end, I'll talk about a Japanese philosophy called Kaizen, which says that continuous improvement. It is a belief that a small change can lead to significant improvements over time. So if you have not adopted to test operations, this is a time. A small step will go big, will lead to a significant improvement over time. I'd like to finish my presentation with that. Thanks a lot for listening me patiently.